All right, this is from the 2009 Form B test. It's number 4, which means we don't get a calculator on this. So we have this polar curve to the right, and we want to find the area of the shaded region. So I know at theta equals 0, the polar curve is going to be at -1. So this is where we are at theta equals 0. We need to find the theta value that will cause the graph to go through the origin. We know the graph goes through the origin when r is equal to 0. So 0's got to be equal to 1 minus 2 cosine theta. So cosine theta has got to be equal to 1/2. So that theta value is going to be pi over 3. Remember, the area for polar is given by 1/2 the integral of r squared d theta. So our area will be calculated by 1/2 the integral from 0 to pi over 3 of r squared d theta. So that's part A. Part B. Write expressions for dx d theta and dy d theta in terms of theta. Okay, so let's go ahead and make an expression for both of those. So we know that x is equal to r cosine theta. So for our problem, it's going to be 1 minus 2 cosine theta, cosine theta. And we're going to do the same thing with the y. Y is equal to r sine theta. So for our problem, it's going to be 1 minus 2 cosine theta, sine theta. And we just got to take the derivative of both of them. So looking at the first one, I think it'd be a little bit easier if I distributed the values. So cosine theta minus 2 cosine squared theta. Take our derivative with respect to theta. So minus sine theta. Here we have to do a power rule. And then a chain rule, which means I'd multiply by negative sine theta. So I'm going to change that to a positive. So there's your relationship for dx d theta. And dy d theta is going to be basically kind of the same thing. I'm going to go ahead and distribute it first. So y is equal to sine theta minus 2 cosine theta sine theta. So dy d theta, just taking the derivative of that, would be cosine theta. Now we have a product rule, so I'm going to leave the 2 out in front. The derivative of cosine is minus sine. Copy down the second one. The derivative of sine is cosine, so copy down the first one. And there's your expressions for both dx d theta and dy d theta. Part C. Write the equation in terms of x and y for the line tangent to the curve at pi halves. Show the computation that leads to your answer. So we want everything to do with pi halves. So the first thing I'm going to need to do, if I want a tangent line, is we're going to need a point and a slope. The points are going to come from the x equation and the y equation. You can just plug in pi over 2 there, or we can look at the graph. At pi over 2, we know that our point is at x equals 0, y equals 0. But if you didn't notice it on the graph, you can just go ahead and use the equations. The second thing we need is the slope. So remember that dy dx is the same thing as dy d theta over dx d theta. So I'm going to first find dy d theta at pi over 2. So at pi over 2, cosine is 0. So we have 0 minus 2. Sine of theta is 1, so minus 1 plus 0. So dy d theta is equal to 2. We do the same thing with dx d theta at pi over 2. So that'd be negative 1 plus 0. So my slope is negative 1. So I know that this would be 2 over negative 1 or negative 2. That should be my slope. Let's go back to our graph and make sure that we do in fact have a negative slope. And we do at that point. Okay, so the equation of the tangent line would be y minus the y value is equal to the slope, x minus the x value. So y is equal to negative 2x plus 1 is the equation of the tangent line. So how was it scored? Part A is worth 2 points. You get 1 for writing the integral correctly, and 1 for writing the limits and the constants correct. So having this and this correct, and the other point is from having this piece correct. B is worth 4 points. 1 point for coming up with the equation for x, 1 point for coming up with the equation of y, and then 2 for the answers. C, 3 points for this one, 1 for the values of x and y, which you could have gotten from the graph. 1 point for finding dy dx, and 1 point for writing the equation of the tangent line.